Hey guys, today we're going to learn about how to find derivatives of exponential and logarithmic functions that have bases other than e. In the past, we've done the derivatives of e functions as well as ln functions, which are logs that have a base of e. So today we're going to look at when we have bases that are something other than e, such as some other number. So here we go. These are the rules for derivatives of these kinds of functions. So you'll see that we have x, which represents, just x, and u will represent some function, and a represents the base of whatever function it is that we're working with. So first we're going to look at how to find the derivative of something like a constant raised to the x. And the derivative of that would just be the ln of the base times the exponential function itself. If the actual exponent is a function, then the derivative of that exponential would be the ln of the base still, copy down the exact exponential function, and then you multiply by the derivative of the exponent. If you have a logarithmic function with a base of some constant a, then the derivative would be 1 over ln of the base times the x. However, if you have another function here, so u, then the derivative would be the same, 1 over the ln of a times u, whatever that function is, and then times the derivative of that function. So let's have a look at some basic derivatives of exponential and logarithmic functions. We have y is equal to 3 to the x. So here the base is 3 and our exponent is just x. Therefore the derivative y prime would be the ln of the base, so 3 times the exponential function, 3 to the x. And this would be your derivative. Please make sure that you put parentheses around what you're multiplying to indicate that it is not part of ln. Otherwise, it kind of looks like it's all together. For b, we have y equals log base 5 of x. So the derivative y prime would equal to 1 over the ln of the base, so 5, and then times the function, which would in this case just be x. Now, you can leave it like this. However, an easier way to write it would be 1 over x ln of 5. That way you don't have to put any parentheses around what you're multiplying because the x is clearly not part of ln. Now let's have a look at some other more complicated type functions. Here we have y is equal to 4 raised to the 3x. So the exponent is now not just x, but it's another function. So this would be considered u. So here I put some boxes to help organize your work. You don't need to do this every single time, but we're going to do this just so that we can identify what is the base, what is the u function, and then what is u prime, so that we can put it all together in our derivative. In this case, a, which is the base, is 4. And u, as I indicated, is 3x. Therefore, u prime would be 3. So now when we're finding the derivative of this, the derivative would be y prime is equal to the ln of the base, so 4, times the exponential function, which is 4 raised to the 3x, times the derivative of the exponent, which is 3. Now you can leave your answer like this, or you can write it a little nicer, which would be bring the 3 to the front. So 3 ln of 4 times 4 raised to the 3x. Moving along to this next one here, we have y is equal to log base 3 of sine of x. So sine of x is our u function. A is the base, which is always this little number here, so 3. U, as I indicated, is sine x, and so u prime is cosine x. So now when we find the derivative, y prime is going to equal to 1 over the ln of the base, so 3, times u, which is sine of x, and then times, all of that is going to get multiplied by cosine of x. Now, if you just actually multiply this is over 1, you can multiply numerator with numerator, denominator with denominator, which gives you cosine x over the ln of 3 times sine x. Now this can be simplified even more because we have cosine over sine. And as we know, cosine divided by sine is cotangent. So my final answer would be written as cotangent x over the ln of 3. Moving along to some other derivatives, we have y is equal to 5 raised to the x squared. A is the base, so 5. U is the exponent, so x squared. And u prime would be 2x. So now the derivative, y prime, is going to equal to the ln of the base, so 5, times the exponential function, 5 raised to the x squared, times the derivative of the exponent, which is 2x. And again, we can write this a little nicer if you like. Y prime would equal to 2x ln of 5 times 5, times 5 raised to the x squared. Now, since this is all being multiplied, it does not necessarily matter the order in which you write it. I just typically like to write it out like this. For b, we have log of x plus 3 to the 3 plus 3 raised to the x. So a here, even though we don't see the base, if you don't see the base for log, the base is always 10. U is x plus 3 raised to the x. And now when we find the derivative of that, we have 1 plus, and now we have this exponential function. So it would be the ln of 3 times 3 to the x. And now let's put all of this together. So f prime of x would equal to 1 over ln of the base, so the ln of 10, times u, so x plus 3 to the x, and all of that is going to get multiplied by the derivative of u, so 1 plus ln of 3 times 3 to the x. Now again, we can put this all together by multiplying straight across. So my final answer would look like f prime of x is equal to 1 plus the ln of 3 times 3 to the x all over the ln of 10 times x plus 3 raised to the x. Moving along here to c, we have another exponential function, 4 raised to the 3 minus x squared. Now a, here my base would be 4, u would be 3 minus x squared, and so u prime would be negative 2x. And now we're ready to write the derivative. So g prime of x would equal to the ln of the base, so 4, times the exponential function, 4 raised to the 3 minus x squared, times the derivative of the exponent, so negative 2x. And again, we can just rewrite this as negative 2x times the ln of 4 times 4 raised to the 3 minus x squared. Last one here, we have log base 2 of the cube root of 2x plus 1. Now, if I were to rewrite this, we have h of x is equal to log base 2 of 2x plus 1 raised to the 1/3. You can definitely use u to be 2x plus 1 raised to the 1/3, but then when you find u prime, you're going to have to use the chain rule, which could be kind of annoying and, a lot more work. So instead, if I apply the power product of logs, right, this exponent becomes a coefficient of log. So actually, h of x would equal to 1/3 of log base 2 of 2x plus 1. And now u is just the 2x plus 1, so it's much easier to find u prime. So let's go ahead and label here what a, u, and u prime is. A is my base, so 2. U would be 2x plus 1, and so u prime would be 2. And now we're ready to find the derivative. So h prime of x is going to equal, we have this 1/3, so 1 over 3, times 1 over the ln of the base, so 2, times u, which is 2x plus 1. And all of this is going to get multiplied by 2. So now I can put all of this together if I just multiply all three of these fractions straight across. And so my final answer would be 2 all over 3 ln of 2 times 2x plus 1. Let's go ahead and look at another question. Here we're going to find the equation of the tangent line for f of x, which is 6 raised to the x, when x is equal to 2. Now you have to remember that for the AP exam, finding the equation of the tangent line is one of your most common questions. And you have to be able to find the equation of the tangent line no matter what kind of function is given. So we always start with the same thing, which is when you're finding the equation of the tangent line, we need two things. We need the point of tangency and we need the slope of tangency. So first I'm going to go ahead and find the point of tangency. And in order to do that, I need to plug in this x is equal to 2 into my function. So I am going to look for f of 2, which f of 2 is going to equal to 6 squared, which is 36. Therefore, my point of tangency would be 2, 36. Now I need to find the general equation for the derivative so that then I can plug in 2 in order to get the slope. So f prime of x, this is your basic exponential function with a base that's not e, right? So the exponent is just x, so you don't have to worry about u. So the derivative would be the ln of the base, so the ln of 6, times 6 raised to the x. And now I'm ready to find my slope, so I can go ahead and plug in 2, which would equal to the ln of 6 times 6 squared, which is equal to the ln of 6 times 36, which you can write a little nicer to be 36 ln of 6. Now, because this is typically not a calculator question, you are not expected to actually figure out what this number is. You can just leave it like that to represent your slope. So now we're ready to write the equation of the tangent line. So y minus 36 is equal to my slope, which is 36 ln of 6 times x minus 2. And this would be my equation. Now we're going to go ahead and look at a sample FRQ with the calculator. So I'm going to open up my calculator here, and we're going to use this to answer the question. So actually, let me put this down a second. So this question reads, your parents bought you a brand new car at graduation. Assume that the value of the car is given by the function v of t is equal to 25,000 e raised to the negative 0.1 t, where v is the value in dollars of the car and t is the time in years from the date of purchase. How much was the car worth at the dealership? So when you're at the dealership, what we need to figure out is what does t equal to? Since t represents the time in years, when you first buy the car, no time has passed. So that means that t would equal to 0. So in order to find the value of the car, we are looking for v of 0. So now what I'm going to do is I'm going to go to my calculator. I'm going to go to my y equals, maybe I should turn it on, and I'm going to go ahead and plug in this function. So 25,000 e raised to the negative 0.1 t, so remember we just put x. And also remember, whenever you're using the negative symbol, don't use the minus sign or you're going to get a syntax error. There's this symbol here that represents the negative symbol. So now I'm just going to go ahead, I'm going to check my window, I'm going to put my standard viewing window just in case, even though we're probably going to have to adjust it, but just so that way we can remind ourselves on how to adjust our window. So when I first graph using my standard viewing window, I I get nothing. And that's because my graph is probably located somewhere else. So I'm going to go to zoom and I'm going to go scroll down to zoom fit. And now I can see the bulk of my graph. So what I'm looking for here is a function value. So when I go to my second calc menu, it's option 1 for value. Press enter and we're going to press x is equal to 0. And we get that the y value is 25,000. So this means that the value of the car, or rather, the car was worth 25,000 at the dealership. When you're writing your answers as statements, make sure that you follow the same verbiage as the question. Now, I didn't necessarily need to use the calculator in order to find this value. If you look at the equation, this is your typical P raised to the RT equation, where P represents the principal, E is, the negative 0.1 is the rate of depreciation, and T is time. So P would be your principal, which is the initial value of that particular expression, So that is the initial value of the car. Now, how much did the car depreciate during its 4th year? If it's during the 4th year, that means that it's at the start of the 4th year to the end of the 4th year. Now, when you're thinking about how time passes, when t is equal to 1, that is the end of that first year. When t is equal to 2, that's the end of the 2nd year, and etc. So if I'm looking for how did it depreciate during the entire 4th year, that means that I'm looking for the change in value. And whenever you're looking for change in value, that is slope. So if I'm looking for during the 4th year, that means that I need to find v of 3, the value at the beginning of the 4th year, which is the same as the end of the 3rd. I'm going to subtract from v of 4, which is the end of the 4th year. So this is the change in the value over the year. And we're going to subtract by 3 minus 4. Because remember, this is slope, right? So y2 minus y1 over x2 minus x1. So now what I need are these two function values. So again, I'm going to go ahead and use my calculator for that. So I'm going to go back to my second calc menu, go to value, and I'll press 3 for my v of 3, and I get 18,520 and 0.456. So I'm going to go ahead and write that down. And I'm going to now find v of 4. So I'm going to, when you're looking for function values, you don't have to go back to the calc menu every time. And that's the only one you don't have to do that for. But if it makes you feel better, you can always go back. But I'm just going to go ahead and click on 4, and it's going to give me my function value for when t is equal to 4, which, as you can see, is 16,758.001. And divided by 3 minus 4, which is negative 1. So now I'm going to go ahead and subtract. So I'm just going to exit here a moment. I'm going to put 18,520.456 minus 16,758.001. And I get 1762.455 over negative 1. Which, remember that this is represents money. So when I write this out, this means that the car depreciated by 1,762.46 cents. So when we're writing our statement, we would say the car depreciated $1,762.46 during its 4th year. For part C, it says, when you graduate from college, what is the instantaneous rate of change in dollars per year of the value at t is equal to 4? Why is this different than your answer in part B? Now, whenever you see instantaneous rate of change, that is just another name for the derivative. So we have two types of rates of change that we're going to be talking about later on in the course. We have instantaneous rate of change, which is the f prime, or in this case, v prime. And then we have the average rate of change, which is when you do your slope calculation. Now we know that the secant line, which is this, what we're finding our slope because we're using 2 points, should run parallel or close to parallel to the tangent line. So when you're finding your slope using slope formula, what you're doing is you're finding an estimate of the derivative, but the actual instantaneous rate of change, that is the actual derivative at that particular point in time. So average rate of change is over a period of 2 points of time, so you're given an interval, and instantaneous rate of change is the derivative at that particular 1 point in time. So what we're doing here is we're finding v prime of 4. Now you don't have to actually find the equation for the derivative since this is a calculator question. What we need to do here is just use a calculator. So I'm going to come back here, I'm going to go back to my graph, I'm going to go to second calc, and I can use the option dy dx, which is option 6, and that represents the derivative. So now I'm going to go ahead and put 4, because I want the derivative when x is 4, and I get negative 1,675.8. So negative 1,675.80. I'm putting 80 because remember that these numbers here represents the rate of depreciation. So this is money. Now, why is this answer different than the answer in part B? And that's because part B represents the average rate of change over the entire 4th year. Lastly, we have when will the value of the car reach $12,500? So what this means is that we're looking for when V of t is equal to $12,500. Now the calculator cannot calculate a particular t, or in the calculator, a particular x value for some particular y value. But what it can calculate is the zeros, so your x-intercepts. So what we're going to do is we're going to set this equation equal to 0. So we're going to make v of t minus 12,500 is equal to 0. So all I did was I subtracted it over to v of t and made it equal to 0 so that now I could find t. So we're going to go to the calculator and I'm going to have to adjust my equation because what I have graphed right now is just v of t. So I'm going to go to the end here and I'm going to put minus 12,500. And now I'm going to go ahead and graph. Now when we graph, you can see that the graph has shifted downwards, and that's because of that minus 12,500. Now when you look here, this dotted line represents the x values, but it's not my x-axis. If the calculator is going to calculate your x values, right, your x-intercepts, we need to be able to see the x-axis on the window. So we can just go back to zoom fit if you don't want to guess as to how far we need to go. And here we can see the x-axis, and we can see to the left of the x-axis and to the right of the x-axis, which when we're finding the 0 in the calculator, we need to be able to see that change in signs. So I'm going to go to second calc. I'm calculating the 0. Remember, it's going to ask us for the left bound, so I'm going to go to the left of my x-intercept. So somewhere around here looks fine. And now I'm going to go to the right of the x-intercept. And here what I do is I just kind of look at the y values, since to the left it was positive and to the right it should be negative. So I'm looking for when the y value is now negative. So I can press enter, enter again, and I get that x is equal to 6.9314. So this means that the value of the car will reach $12,500 when t is equal to 6.9314. And that's it.